Hello, everyone. Welcome to another binary episode of the Day Zero podcast. Inspector with me is Z. Today, we have some unfortunate news around Libfuzzer and some router and firmware bugs. So we'll start off with the news. So this was a little bit late. This happened in, I think it was like July, like middle of 2023, but it's something that went kind of unnoticed, and I searched around and it doesn't seem to have been covered elsewhere either. But it's the fact that Libfuzzer from LLVM seems to have stopped active development. It is still supported. It's still going to be receiving bug fixes, but the active development is going to be stopped in favor of instead supporting Google Centipede, which is integrated into Google's fuzz test framework. And yeah, it's a bit unfortunate because Libfuzzer is a pretty cool project. I think we've even talked about it a fair amount, either in the podcast or just in general on streams, because it's gained a lot of traction as like a useful fuzzing platform that you can quickly get started with. And yeah, it kind of sucks that it's like it hasn't even really been around for that long, right? It sucks, but
Yeah,
yeah,
I mean
so
it
something we
it
did want to bring
does
up.
it does definitely suck. Libfuzzer was my favorite to recommend when it came to developers wanting to add fuzzing into their code into CI/CD's work because it is so if you're using like Clang-based tooling already, and actually even like GCC I believe has support for at least a simple Libfuzzer, as does the Microsoft compiler, like Visual Studio compiler.
In
Both
this
do have
VC, yeah.
flags. Yeah, both do have flags for Libfuzzer so they can do things very similar to it. Nonetheless, it is disappointing. This was kind of thing for developers, again, especially around Clang-based tooling. It's very easy to start writing some test cases and writing fuzzers for their program, and like to compile it, you add a compile flag, f sanitize equals fuzzer. You literally just add that. I mean, there is a little bit more complexity with like a no link when you want to do the fuzzing, like library and some stuff like that. But ultimately, it is a very easy fuzzer to work with that has source access. So for developers to do it, it was just one of the simplest tools to get them with a relatively effective fuzzer going. And so that was like a favorite place to recommend. And of course, doing any sort of fuzzing on open source code, it's really easy to work with a library, add in your test case, then you can build your fuzzer very easily. Unfortunately, so the Centipede fuzzer that Spectre talked about is where the authors of Libfuzzer basically have stopped their active work and they're now working on this other fuzzing engine called Centipede, which at least tries to be somewhat compatible with Libfuzzer. Like it still supports the like test input for Libfuzzer and kind of has some similarities there. The output has some similarities. So like it is obviously has some inspiration from it, but it is more of a standalone fuzzer that then runs your fuzzer itself. So it changes the architecture. It's to having like this external fuzzer, like fuzz manager. Has some support for like an executor, so you can like do some more swap outs that were maybe a little bit harder to do with Libfuzzer. The Libfuzzer was fairly pluggable too, but the main thing is it just becomes, even though it's not necessarily complicated to build, it is nowhere near as easy to build with it anymore. Because now you need to build Centipede and you need to do the build for your fuzzer as kind of like separate things, as like your fuzz target as separate things. It adds this layer of complexity that just, I don't know. The thing I liked about Libfuzzer was its simplicity, super easy to just get up and going. You add this little bit to your code and you've got a fuzzer.
Yeah, I mean,
Genuinely
it
that
handles
easy.
all the complexities that you have with fuzzing under the hood, right? Like with this, it's more tightly, like it's not as decoupled as Libfuzzer was. Like Libfuzzer, you just add the function, you add the flags, and you're able to build on top of that very quickly. Whereas with this, like you said, it's more coupled into the fuzz test framework. So yeah, it's kind of unfortunate. It's also, I mean, it's kind of a meme at this point, but I don't really know about jumping onto a Google project bandwagon. I feel like there's been a few like fuzzing based or like security based projects from Google that just never went anywhere and just died, like a lot of Google stuff does. So I really like I'm kind of saddened by the move. I'm not gonna lie. Like I like LLVM tooling. I like the whole LLVM project, and Libfuzzer was a great component of that. And yeah, it seems like it's being killed in favor of a Google project that might get killed too. So
Yeah,
that
I
that kind of
mean,
sucks.
I think Libfuzzer was a Google project initially too. Like I do believe that was initially
Actually, it
added
might
into
have been.
LVM through Google.
I think you're right, actually, remembering back the history now. So, fair
So
enough, I guess. It's
like they
returning
did
home.
bring it to fruition, but at the same time, like, Centipede does not capture, as far as I can tell, the same
The
focus
same
and like
use
the same,
case.
yeah, the same use case. I could absolutely see myself using Centipede as a researcher and using it to do that. No problem there. I can, learn something, build things. I understand like what a fuzzing campaign looks like. Yeah, I get that. And when it comes to the corpus, I think it still has a lot of similarities with how Libfuzzer works. So, that's fine. It's just a little bit more complex to do this. And they do try and make it somewhat easier to do these builds too. Like they do provide just like the clang flags file that you can just use at and the path to it to have the flags in the file added to your builds. Like they do some things to try and make it easy enough. It really just comes down to the fact that, this is very much feels like a research tool now. It's got a lot of the things that you'd want in a managed fuzzing campaign at the cost of what's harder in a sense to integrate this as a developer who just wants to integrate fuzzing. So I don't know. I mean, it seems like they're doing some nice things with Centipede. I'm not going to lie and be like, oh, Centipede sucks or something because they're getting rid of Libfuzzer. They're definitely trying to remain with some degree of support for Libfuzzer campaigns. And I think part of that's because oss-fuzz, a lot of the fuzzers in oss-fuzz, which is Google's big open source fuzzing thing, use those sorts of test cases. And there can be some benefits here with using fuzz tests as like their generic framework for all their fuzzing going on instead of Libfuzzer specifically. Like there is probably some reason around that as to why they're making this shift, but it definitely disappoints me. But that said, Libfuzzer on a whole, like as if it's getting the bug fixes, like there aren't a lot of features. There are features that I would love to see in Libfuzzer, don't get me wrong, but it is somewhat complete. Like it does what it needs to do. And things like the coverage and all of that Libfuzzer would depend on, that's done through SandCov. That's done through other sanitizers that are part of LLVM. So it's not like any sort of upgrade there is going to disappear. You're still going to be able to get some of that as the sanitizer upgrades. Although you could start having some incompatibilities if that coverage information Libfuzzer doesn't or no longer knows how to parse. Um,
So I think that would fall under bug fixes, probably. So,
well, I'm imagining more if they had new coverage styles, like new features, new things to track, rather than
oh,
just
I
like
see what you
no
mean.
support at all.
Yeah, I gotcha. Okay.
Like I imagine we're still going to keep our baseline and they'll keep that working, which is important. And in fairness, like Libfuzzer does feel somewhat completed. Obviously, there's always new fuzzing development to do, but Libfuzzer kind of has a pluggable interface that you can add things in with to get that. So like
It
it's
provides you the
kind of,
base.
yeah, like we still have something there. It's not like Libfuzzer's disappearing tomorrow. It's just disappointing, I think, to see the loss of resources on something that I feel is very important for like just software security in general, not even the research, because I think a lot of people do use other fuzzers besides Libfuzzer. But Libfuzzer, I think, was one of the big improvements when it came to getting like software teams to adopt security and fuzzing as part of the life cycle.
Yeah.
Um,
And like you said, like it is still getting bug fixes. It's not like it's dead, but LVM is fairly modular. So the point that you said about like sanitizer coverage and things like that being upgraded and being able to inherit those improvements, it's not something I really thought about, but it's true. Where LVM is modular like that, you do kind of get the benefit of inheriting upgrades to the components that integrate with Libfuzzer, even if Libfuzzer itself isn't getting active development. So yeah, I mean it's at least for the near future, it's probably not a big deal, but down the line, yeah, it kind of sucks.
yeah, I mean, maybe somebody else will even step up and kind of take over the project. I don't know. The only reason I found out about this was somebody in chat. I don't even remember why Libfuzzer came up. They're like, oh, isn't Libfuzzer deprecated? I'm like, no, let's take a look. And sure enough, I found the status thing here. Unfortunately, I would give them credit. I wish I remembered who it was. I don't remember their name exactly right now. But that's like the only reason I found out. So I have to imagine other people, because I use Libfuzzer. Like, it's not like I don't follow anything, but I had no idea about this. So I assume others are going to similarly kind of be unaware.
Yeah, it's kind of hidden. Like I said, I looked around for like any announcements that Libfuzzer was being deprecated in the active development. I couldn't find anything. And I gotta say, it's not very, like, even though I use Libfuzzer, it's pretty rare that I go to the Libfuzzer docs page and would be reading that status. So yeah, I imagine a fair amount of people who use it out there might not be aware. So it's kind of a PSA,
Yeah, and release
trying to give it
notes
some
even
attention.
for so this change happened with the introduction of Libfuzzer 16 specifically.
LVM
Um
16. Yeah.
yeah, sorry, LVM 16. That's the first one that actually had this status added to it. Um, but the release notes for 16 make no mention of this change either. So it was a little bit hidden, just like they moved off onto something else, and we're just going to keep doing bug fixes here, not really do anything new. And
Yeah.
calling it deprecated may be a little bit harsh because it's not like it's recommended not to use and you should move away from it. It isn't quite deprecated, but it's also it's in maintenance mode or feature lock mode or whatever you want to call it. Feature freeze.
Yeah. And like you said, maybe it'll get picked up again at some point, but only time will tell. So we'll get into some of our vulnerabilities of the episode. It's a bit of a Syslog special. We were actually joking a bit before the podcast started because we had got a bit confused and basically blended the topics together because both of them involve Syslog, but they're different issues. So we'll start off with this one. So this is an advisory that was a qual-sys advisory, and it was a heap overflow in glibc's syslog functionality. So I'll let Z cover this one.
Yep. And this is, I think Qualys, however you say their name, they have been doing a lot of work kind of on these. Like they found the pseudo bugs lately. I think the Baron Samedit is kind of the I think well-known one, but they've had some other kind of like similar bugs in these core pieces of software that probably don't get looked at all that often. And so this one is like right in glibc's syslog. So, if you're making logs out like that, any software is potentially vulnerable to this sort of heap-based buffer overflow. The main concern is that the log can't already have like a log tag set up. And by default, if you just start writing to syslog, you don't actually need to open a log. And when you open it, you would give it the tag. But if you just start writing to or making like syslog calls to log it out, it'll just default over to the prog name, which is the base name of whatever like the argv or the first argument is, which is your binary that usually, or by tradition, it's the binary you're running. It's using that value, and that value is going to be very important to this overflow, and that's kind of the requirements to this overflow. But I'm going to talk just kind of about the code flow here. And for that, I'm going to pull up the old code. So this is the vulnerable version of the code. I do have a repository here that has the glibc code and seems to be mirroring it, but I don't think this is an official GitHub repository. I believe C is hosted elsewhere, not on Microsoft content. Pretty sure they want to avoid that, but the code here itself, as far as I know, is the same. So let's step through this. Vulnerability exists inside of this v-syslog internal. So just one of the function that it's called. Like, a lot of the other things will wrap these and provide different arguments depending on what you're doing until you finally reach like the internal function that actually does like the hard work and does whatever the function's supposed to do. And you just have a bunch of more convenient user wrappers above it. So ultimately, like the syslog calls lead into this function. And up at the stop does some usual things, sets up variables, creates this buffer of 1024 bytes called buffs. Then there's also a buff, which is just set to null, and that is a character pointer. So when they allocate, or if they allocate a new buffer, because the content won't fit inside of buffs, that will get the pointer. And then there's also a buff size, which tracks the size of the buff character array. If it gets allocated, so of course it starts off to 0. That makes sense. We come down, there's a syslog stuff, so you get into that log tag aspect I was talking about where he uses the prog name or the base name of the program. Again, things are kind of making sense here. And then we start getting into code that leads to the vulnerability. They create this L variable. That's going to be a length variable. I really hate that they call it L because it blends in with the number 1. So it's like you have
That
buffs
threw me
plus
off a
L.
few times.
Yeah, it's hard to read code because you have like some of these points where it's like, is that a 1 less than size of buff or is that a L less than size of buffs? Like it's, if depending on the font you're using, it should make it more or less obvious. And like in this case, you can kind of make it out, but because they use 1 throughout this code, like they do a +1 at one point. Like down here, we get the color coding, but it makes it a little bit tricky to read. Anyway, you've got this L, which is a length, and that's just going to do the printf, or well, it's doing an SN printf to buffs. So that is that 1024 byte character. That's just going to be like their static buffer they start with and gets the return value of that. They have 2 calls to it. That just has to do with the formatting option. Mainly what comes back here is just, it's writing the header to the buffer at this point. And then it does this check 0 less than L and L less than size of buff. All that's doing is, because smprintf, when it returns, it's going to return how many bytes it would have written, not necessarily how many bytes it did write. And that's because you specified value, that size of buff, so 1024. You're specifying that as a maximum like amount to write. So if the return value is greater than that, it didn't write all of it. It only wrote the first 1024, or it only wrote the first byte, and then whatever else wasn't written, but this is how many it would have written. So the idea of this check is basically to say if L was less than the size of buffs. So if it was less than the buffer, we still have room in the buffer after kind of we wrote our header, then let's keep using that buffer. And they come through the code and they do the next VSN printf internal call, which is effectively just writing the rest of it. They're getting the format string, they're getting all of the variable arguments, and then they're writing that out. And then again, they do that check for, this time they're using VL as it for the VSM printf, but they're checking the length again there, making sure it didn't go over. If it didn't go over, so it all still fits inside of buffs, then it would set the buff, that character array they had, it would set that to the value of buffs, so just make buffs that and kind of keep going. If it didn't, like if it was too big though, the buff would remain null, but it would update this buff size as being the length. So the first length value plus that VL length value, you'd get both of those. That would be the buff size. So then when we jump through the rest, or when we fall out of that code, we end up at a, if buff is null, it's going to initialize buff. And to do that, it's going to take the buff size +1. Now, here's kind of the problem. That whole bit of code with the VSM printf, you're only going into that code. If that first SN printf was less than the size of buffs, if it was less than that 1024 characters, if you don't go into that path, you can still fall into this check of if buff is null. But the problem is buff size only gets updated if you fall into that path. So buff size is going to be 0, and it's going to allocate a buffer of 0 + 1, or 1 byte times the size of a character, 1. So it's going to allocate, 16 or whatever the minimum is for malloc, but it'll allocate a very small buffer. But when it's actually writing things, it's using that L value again, and it's, definitely not. And I guess we'll use buff size down at the internal call, buff size -1, so 0 - 1. Again, leading to a fairly large value coming out there. So basically, when that is 0 and getting through here, if you don't fall into this code path, this other path is just likely very, very wrong. But most cases aren't going to write more than 1024 bytes in their header, so you don't really fall through this path. It really feels to me like... Oh, go ahead.
Sorry, I was just going to say that's one thing that I was thinking when I was reading through it. It was like, when this flow goes, there's no way it can be done correctly. It's just impossible for it to be done correctly. So it just must be like an untested control flow or something.
Yeah, just a flow that wasn't really being encountered because you never really have that much data being written into. Because the syslog header, in the worst case scenario, is basically like integer timestamp, integer, and integer. Like, it's not a lot of data in there. PRI believes an integer, timestamps the string, message off and PID are both integers. So, like, a lot of the things being written in here aren't that big. You're not really going to reach that 1024 bytes very quickly or very easily. However, because of what we talked about before with that control over prog name, in the case that log tag isn't used, that means you can have that be as long as you like, because you can control what argv0 is, and the base name is just going to parse from the last slash. So you can parse, or you can technically like use execv or something to start up a program as like anything there, or even just calling like rename a binary or whatever. You can give a very large value in that. So as long as it gets everything up over that 1024 bytes, you won't fall into this initialization code, which then means you'll hit this with buff equals to null, and you'll end up having basically writing to a very small buffer, or having the data written out to this small buffer, which is pretty beneficial. Gives you a pretty direct like overflow into the heap. Getting into the exploitation, one of the routes they went is they used a kind of technique that's mentioned as being relayed to one of their exploit techniques for bear and same meta. I don't recall the exact one that they used there. They had a few, and this isn't the one that I had liked, but whatever. But what they do have is they use, basically they overwrite just in adjacent memory. They're able to get an NSS module, overwrite the name, which is inline character array, to include slashes. And so when it's loading the module, it's going to take that name. It's going to use those slashes as like directory traversal. And so you can get it to load a shared library from a potentially attacker controlled location that isn't like the original or any sort of original library, because you corrupted the base name for it. And so you get code running inside of like they did the exploit inside of SU. Sorry, I should have mentioned that. Where they decided to try and exploit this was the SU binary, which is a setuid binary. It's running as root. And then they get that to load this binary through the corruption there. You can kind of read the post for more details on it, but I did appreciate that they went for more the data-oriented route to get the code in there rather than just trying to get shellcode or something. And they also talked about using fuzzing to find... go ahead.
They did kind of try it. It's just because of the constraints of their exploit scenario, it wasn't super viable. Like, they initially tried targeting these function pointers in the PAM structure, but because they couldn't inject null bytes because they're dealing with a string, and it's, they're targeting a 64-bit binary, like that option wasn't really open to them. So they were kind of forced into doing a data-oriented attack with attacking the strings of the NSS stuff.
Yeah, I mean, they could have pushed harder. I don't know. Either way, like, I appreciate the fact that they went this route, and they've done that with their past bugs too, where they've had some of these more data oriented exploits going on, which is just kind of nice to see, because I think it's a more elegant attack strategy. And I also want to call it that they do talk about how they found some of their primitives for doing this was through using fuzzing to find their primitives. We've talked about that, I think, a long time ago when we talked about Kobe, the kernel like out of bounds object exploit. I don't know. They use fuzzing to find or to try to enhance their like heap overflow primitives. In this case, they're using fuzzing to try and find like their primitives. It's just a technique that I don't see brought up very often versus like trying to actually analyze the code and figure out what you can reach. Just fuzz it and see what type of crashes you raise, which is what they went for here. Just kind of a technique I figured was worth throwing out because it is very valuable, can save you quite a bit of time depending on how you do the fuzzing, and there are some question marks for it, but it is worth being aware of, and I don't see it brought up very often.
Especially where over the last like 5-10 years, we've seen a big shift in the meta of defending against exploits, targeting the exploits themselves more than the vulnerabilities, because people have realized vulnerabilities are always going to exist, so let's try to mitigate common exploit strategies and stuff like that. So fuzzing for getting your primitives and whatnot is a useful tool that I think probably should be more common than it is. And maybe as time goes on, it will grow in popularity. But yeah, it's a great technique that's just not really talked about much.
Yeah, I mean, it saves you the analysis time. It can find things that your analysis wouldn't have found. And the other thing is it finds things that actually work. Like you're getting crashes out of it. Because like I can go, especially when you have an open source route, I can go and scan through all the code for all the objects that match exactly what I want or whatever. But then do I know how I'm going to be able to groom them and all of that? Like, no, there are questions about that.
When
So
you're coming up with attack strategies, it's very easy to get caught up in theoretical strategies that aren't very practical. Whereas with the fuzzing, you eliminate that.
yeah,
Yeah.
kind of eliminate that. You get some options and perhaps options you would have never known. One thing I don't want to, talk too much about this, but I will shout out that Artificial Truth did put out a post kind of musings about this CV. They talk briefly about the bug and then how difficult it would be to exploit this on a hardened malloc, mostly pointing out the fact that since this is like a 0 or 1 byte allocation, it would fall into this 16 byte size class. But since all of these sizes are actually padded by 8, they would have to find something that's based an object that is 8 bytes long that has something interesting to overwrite, and you can't go outside of that size partition. Basically making it quite difficult because I mean 8 bytes isn't a lot. That's like literally a structure containing 1 pointer, not even 2 pointers. On the 64-bit system at least. So yeah, they talk about how things kind of become a bit more difficult. Might be worth a read. It's not a very long thing here, very deep, but they have, as I say, some musings about. So I just want to give them a quick shout out, and their blog a quick shout out.
So we do have another topic that brings in Syslog. So this is a post by Shielder on vulnerabilities that were patched in Asus routers that were diffed and analyzed by researchers at Shielder. All three of the CVEs that they mention here asserted unauthenticated RCE was possible with them, which got them curious because they're fairly bold claims. So they patch diffed and got some emulation set up with Keyling, as they didn't want to have to buy an Asus router before knowing that they discovered what the vulnerability was. And the main library that seemed to be at fault here was the libshare.so library, and in particular the notify RC and validate RC service function, which checks this RC service field, which comes from a JSON blob. And it turns out that in their logging functionality, they pass a log message with attacker controlled contents directly into syslog's format string. So yeah, it's just a straightforward format string bug, which you don't see too much nowadays. They
So
were
you
able to
say they
confirm.
pass it directly, although I do at least want to call out that it is, in my opinion, a little bit more excusable how it gets there. It comes down to this code here in this log message normal. It's the syslog that has the vulnerability, but it's the VSM printf where they're writing it. So it's kind of one of those where they end up passing it through a format string thing twice. Syslog probably should have been called with instead of the buff directly, should have been called with %s there. But I don't know. To me, this does feel a little bit different and a little bit harder to reason about, just because of the fact that it's, when they're doing the printf of the buffer, it is safe. And then they just log it. And they may not be aware that like the log supports things like a printf. Could be something like that. It's just a little bit more excusable to me than plainly doing like printf with user data as the format string. Not much, but it is a little bit more excusable to me at least.
It's not as immediately obvious, I guess. Yeah.
Yeah.
So fair enough. So yeah, it's a format string bug. They were able to confirm with their emulation that this does indeed work, and then after that, they purchased an Asus router to try exploiting it, which is a little bit tricky because ASLR is enabled. They do have partial read-only relocations, and it does have no execute, though it's not compile disposition independent, nor does it have stack canaries. But additionally, they also have some restrictions on their input payload. Because this RC service variable comes from JSON, they couldn't break the JSON body. They could kind of get around that by using raw bytes and double encoding, as well as UTF encoding for adding a null byte on the end of the string, but they're also limited on length. So, as they say, typically with this, they'd find a target to overwrite in the global offset table, overwrite some function in the binary that takes user input, direct that to system, and get shell that way, the classic format string exploit strategy. But they wanted to see if they could find a strategy that wouldn't corrupt the process internals. And what they ultimately went with here was sort of like the last topic with what Z said. They went for more of a data oriented approach. They instead corrupted the system CMD global, which is a string that's used in the syscript function when the syscmd.s string is passed into it. So this system CMD variable would basically get passed into a shell command to execute. And they were able to get that syscript function invoked by going to an endpoint that executes commands. They mentioned two of them. There's the main analysis content or main netstack content, where you're dealing with a router. That happens in a few different places. But yeah, so they were able to use that to get get code execution. But after all of this, what they discovered was that they weren't able to hit this without authentication like the CVE said was possible. And that's because in order to hit it unauthenticated, the router has to be set as not configured, which in real world devices it is set as configured. And not only that, if the router isn't configured, the wide area network interface isn't exposed remotely anyway. So this bug, as well as some of the others that were reported, would basically be impossible to hit remotely on a real world device, indicating that the CVEs were likely found and reported by researchers who emulated and didn't test on real devices. So they said they were a little bit disappointed in that. I mean, it's fair when you're dealing with like IoT stuff, it can be nice to just emulate, test stuff locally, and then make your conclusions based on that. But this is kind of a reminder that you can't do that if you want to be accurate and what the impact of your bug is. So yeah, it was a little bit unfortunate in the conclusion. Like they went through all this work, they managed to get the exploit working, and then the premise was kind of flawed from the jump. It's not able to be hit unauthenticated remotely, but they were still able to get an exploit working, at least in their emulated environment. And like I said, format string bugs, you don't get to see them too often. So when you do see them, even if the context is unfortunately not very impactful, it's still cool to see an exploit for that.
Yeah, I mean, ultimately, this does come down to they still exploited it. They still kind of took it to code execution. And I want to show out there this whole idea of sitting there with the code and trying to do an exploit that doesn't try to like corrupt the process internals, I think is a good practice. Like if you're trying to learn about modern exploit development, and to me, like when I talk about modern exploit development, I generally mean like against the hardened targets and stuff like that, not just like any exploit that exists today is modern. But this whole concept of focusing on the data, focusing on not hijacking control and all of that, I think it's a good practice to get in there because you don't get those same really generic techniques. Like they were going to go just got table overwrite, jump off to a ROP or something, or whatever it might be. Maybe just running to shell code. Um, but I mean, with NX, maybe not. But you have like that very high level generic technique. But whenever you move into the data oriented attacks, which tend to have less mitigations against them, so they're more practical in that sense, more usable in that sense. They tend to be a bit more stable, although that can vary because they're not corrupting the whole control flow, but they also tend to be very application specific. They're using this program happens to have what is effectively like a system, like a function that calls system, or like a win function in a sense, but not everything has that. It's a good practice to just try and come up with these strategies yourself and get practice doing that because that is a skill that I think a lot of people don't really have a good way of learning. And you may, if you're just trying to write an exploit, you may just go the easy route and be like, oh, I know how to exploit this scenario rather than trying to do this and trying to get practice being creative with your exploits and stuff. So I think it's a really good practice.
Yeah, I agree. It's a good way to get into it without necessarily attacking hardened targets, as you say.
Well, I
So
think it's a
yeah,
good practice in general. Like if you're learning exploitation, you have like some easy target to exploit something in multiple ways. And adding on these
yeah,
sorts of constraints to yourself as a way to force you to do that, things important. That is something I actually call out in like our CTF to real world post when we're talking about getting good at exploitation, like is getting that sort of practice so you force yourself to try other techniques and other routes beyond just what you're usually kind of comfortable with and getting out of that comfort zone.
yeah. Basically, what the common techniques are. Like it's easy to just stay in that groove. But yeah, if you force yourself into doing more like the data oriented attacks, it can help you a lot in multiple targets, not just the one that you're looking at that day. So it's a
Yeah,
good
like
point.
you're exercising your creativity really. And every time you kind of explore these different things, you're building up intuition about what may or may not be possible.
Yeah. All right. So those are the vulnerabilities that we have. We do have a few shoutouts. The first of which is the binary post on LogoFAIL. Many of you listening have probably heard of it. LogoFAIL's gotten a lot of traction. It's basically a image overflow in UEFI. I didn't want to give it full coverage because it goes into it's quite specific to UEFI and how they exploit it. They talk about the heap internals of UEFI and whatnot, which I did want to shout out because if you're looking to do research in that area, I think this post does have some useful information for you. Just in their process of trying to exploit this bug, they cover a lot of that ground. But yeah, where it's fairly specific and the bug isn't really that interesting, it's just like your typical PNG parser bug. I didn't want to give it full coverage, but if you're looking into UEFI stuff, it's probably a post that's worth checking out. And it's elaborating on an issue like LogoFAIL has been known about for a little while. I think it was just like talked about in the end of December of last year, and they talked about it at Black Hat, but this is their post that it goes through all the nuances of it. So yeah, feel free to check it out if that sounds interesting to you. Another shout out that we have is Trail of Bits put out a post on a recap of CCC. It's a little unfortunate that it was this late. Z and I were talking a bit before the show and saying like it would have been awesome if this came out when we were talking about CCC, like in the last episode or whatever. But yeah, so they did their own recap of CCC, talking about some of the talks. Actually, there's a bit of overlap. I think they talk about the fuzzing talk that I had mentioned. So yeah, just more perspectives on CCC and some of the talks there, which, as I said before, were great. So recommend giving this post a read as well.
Yeah,
And
they've got kind
yeah,
of the several posts, or not posts, several of the talks. Like they give a summary of what they're going through a bit and like what they found interesting from it. So it's kind of like what we were doing, but from Trail of Bits. And like I kind of said last time, I didn't actually go through and watch anything from CCC. So this kind of gives me a short list of things to at least check out.
yeah. And then our last shout out is one that Z added for oss-fuzz-gen by Google. So I'll let Z cover that one quickly, and then we'll end off the show.
I mean, technically, I did add all of the shout outs, not just this one. But yeah, so this one is it's kind of just follow up on some things Google has been talking about on the Google security blog, where they've been talking about using LLM to generate fuzz cases. I think they've had a couple posts here. Now they're actually putting out a framework for generating fuzz targets, so generating those test cases using LLMs. And now they've got a whole framework here that does support like the OpenAI models or Vertex or Gemini, supports those models. Actually, I don't think any of those are open source models. Is a Vertex AI a open source model, or are these all just API based?
I am not the best person to ask where I'm not an LLM, so I'm not sure. But
Okay, so Vertex AI is from Google themselves, and then
oh,
Gemini.
yeah, that's right.
Then Gemini I thought was from Google. Of course, searching Gemini doesn't give me much. Okay,
I do remember Vertex being announced. When you said that, it clicked in my mind. But Gemini, yeah, I'm not sure.
yeah,
I haven't
actually,
heard of it.
Gemini, like I see a post here about Gemini from Google DeepMind. Gemini is the first model to outperform human experts on massively multitask language understanding. So that's from Google also. And then they have the two OpenAI. So I'm a little bit disappointed that this doesn't support self-hosted or like self-run um ones. Although I guess a lot of like Llama and stuff, you can get a open API compatible API running in front of it to use it, or to probably be able to use it. Yeah, the support seems a little bit off, but like I said, the OpenAI API, I'm pretty sure others have copied that for their to use it with their own API things, or to use it with their own AIs. Fair enough. It'll generate fuzz targets and all of that. It's just basically progress. It's just an update on that's kind of in line with what they've been doing, using it to create fuzz tests and fuzz targets for various projects that probably otherwise don't have a lot of fuzzing. So it really is like kind of what we talked about. AI is able to scale beyond what humans can do. Even though it's not outperforming humans in what it's doing, it can scale and it can do like these really kind of dumb fuzzers, which probably aren't all that complex. I mean, generally speaking, the code generated by these things is not the most amazing thing ever, but it's able to do this on hundreds of projects. They mentioned here 160 C++ targets, which it generates coverage on, which just AI is able to scale and just kind of add on there. So it's cool to see out of Google doing this. I mean, it's really there, I imagine, to support to support kind of oss-fuzz, which is their big open source fuzzing stuff. So fair enough, but it is something that's kind of been talked about for a bit, and now we're kind of seeing something from Google actually implementing it, which is nice to see rather than just being kept quiet.
Yeah, I mean, it's something we've talked about, that fuzzing is a good place that AI could be integrated with generating test cases and things like that. So seeing it getting put into practice is nice.
Yeah.
All right, so that's all the topics we have for today. So thanks everyone who tuned in. You can join our community by joining the Discord and Twitter links down in the description. And previous episodes can be found on YouTube, Spotify, and Apple Podcast. With that all said, we'll see you next week.